to look at what's called mathematical induction. We will have a review on Monday and a test on Tuesday. FYI, I will not be here Monday. I'm taking some students to a competition. Okay? So, if you have any major issues, they need to be cleared up tomorrow or Tuesday morning. Okay? I will also be here Monday morning. We don't leave until 8. Okay? So, you have tomorrow, Monday morning, Tuesday morning to ask questions before the test. Okay? Once you get the hang of it, we're going to take it slow. We're going to break it up into parts. Okay, we're going to kind of talk about what it means today. And we're going to break it up into the setup today, and then we're going to actually go through the entire thing tomorrow. Okay, you notice that you don't have very many problems for your homework. There will be only one of these problems on the test, but it's pretty involved, so it will be a significant amount of points. Okay? So, maybe? Here we go. All right. We're going to realign it.
Calibrate it.
Everything's working very slow today. The network is awesome on this beautiful Thursday.
School's awesome.
Okay, while we're waiting for that to actually happen, in mathematics, we like to prove things to be true. I know it's your favorite thing to do. Okay, yeah. And in geometry, you did some pretty straightforward proofs. Step by step, you said, okay, we have this, so this can happen. We have this, so this can happen. We have this, so this can happen. We have similar triangles. Okay? Mathematical induction is a different way to prove something is true. Okay? And we're just going to look at some simple examples. If any of you go on to upper level mathematics, this will be one of the strategies you will use with more complicated situations. Okay? Okay, now, why are we doing this right now? Mathematical induction is a proof strategy that's actually based on a sequence. Okay? That's why it is thrown into this sequence and series chapter. Okay? So, I'm going to kind of give you the basics, and then I'm going to give you a metaphor to help really understand what's going on. Alright? We like metaphors, right? So, mathematical induction. First of all, we're going to define a function p sub n. And it's going to be in the statement involving a positive integer n. This sounds a lot like a sequence. Okay? Alright? Positive integer n. P sub n. Instead of a sub n, we now have p sub n. Alright? Now, the first thing we're going to do, okay, first term needs to be true. If the first term is not true, we're out the window. We can't do anything. Alright? First term has to be true. Okay? Now, I'm going to read this next statement. You're going to write it down, but then we're going to discuss it in great detail. So do not panic if it doesn't quite make sense yet. Okay? What? integer k, then the truth of k needs to imply the truth of pk plus 1. What does that mean? If pk is true, that means the next term needs to be true. Okay? If we can prove that, then we can say p sub n is true for all n. P sub 1 needs to be true. We need to start it. Then, if we can say p sub k implies p sub k plus 1 being true, then our entire statement is true for any number. Okay? Write it down, and then I'm going to give you a domino analogy. Okay? How many of us have ever lined dominoes up and made them all fall down? Okay? That's what we're going to think about. But it's fun. Okay? You can do some really cool things with setting up dominoes and making them all fall over. Okay?
Yes.
So, I have... Oh, is everybody done writing this down? I'm sorry. Is everyone done writing this down? Okay. Now, I have kind of a long paragraph here for those people at home to read. Okay? Go ahead and read through it. See if it makes sense. Okay? We're going to discuss it, but just read through it. Okay, so basically, we have to start our domino train, right? We need that very first domino to start the tipping over, okay? If we can prove that any domino, any random domino, any k domino is going to knock over the k plus 1 domino, then when we start our train, we know 1's going to knock over 2, 2's going to knock over 3, 3's going to knock over 4, all the way until our n dominoes are falling over. Okay, how do you feel about that? What, Malik? Okay, so we're going to have a sequence, okay? If we can prove that domino 1, see, term 1 is true, we have somewhere to start our train, right? Can I call it a domino train?
Yeah, let's do it.
Okay. Okay, so if I plug in 1 and it is a true statement, then we're good.
Yeah. I was right. No.
We are not going to worry about p sub 1 today, okay? We're going to more worry about it tomorrow, okay? Basically, I'm going to give you, like, this equals this. Okay, it's going to be more of an equation. Okay, we're going to have a sequence that equals something. Maybe a sequence or a series that equals n squared. So if I can plug in 1 and it's a true statement, this actually equals this, then we're good. We have somewhere to actually start our train. Okay? What we're most concerned with today is being able to write the piece of k and piece of k plus 1, because if we can't write that, we can't do our proof. Okay? So tomorrow we'll worry more about the piece of 1, but basically we're going to have a sequence or a series that equals an expression, n squared, n plus 1, something. Okay? So if we can prove n plus 1 is true, we're going to be, that's where we're going to start our domino train. Okay? Then we need to prove for any piece of k, okay, we'll assume that piece of k is going to be true. And if we can show that if piece of k is true, then it makes the next term true. We can say that, okay, this domino is going to knock over the next domino. All right? So if we can say that the domino is going to knock over the next one, then 1's going to knock over 2, 2's going to knock over 3, 3's going to knock over 4. Okay? Is this helping? Okay. Now it's all going to really come together tomorrow. Today we're going to focus on piece of k and piece of k plus 1. Because actually writing those out is going to take a little bit of practice. So your homework today is going to be more about the piece of k and piece of k plus 1. Any random domino, what is the next domino going to actually look like? Okay? Does anybody need a different explanation? Okay. Chase, are you okay with this analogy? Okay. Okay. So our goal, which we're going to discuss it tomorrow, show piece of 1 is true. Then show piece of k implies piece of k plus 1. Okay? And I'll show you how to do that tomorrow. We're going to be more concerned about writing that piece of k plus 1 today. If the first step is true, and each step is based on the step before, then we can say, in general, it's true, all of our dominoes are going to follow. So write this down if you need to. So basically tomorrow we're going to assume this to show this. Okay. So today we're going to focus on writing this. So tomorrow when we go to actually show it's true, it'll be an easy transition to go ahead and write it. All right. Everyone ready? Okay, so what we're focusing on today is just stating piece of k plus 1. So here's piece of k. Please write it down. So let's talk about what p sub k plus 1 looks like. Okay, what are we going to do?
Add 1 to k.
Okay, instead of k, we're going to replace it with k plus 1. So in our numerator we have 6, that's going to stay the same. In our denominator we have k, that is going to turn into what?
K plus 1.
Okay, it's a binomial, make sure it goes in parentheses.
Use Siri at this time of the day.
Instead of k plus 3, it's going to be k plus 1 plus 3, so k plus 4. That is all we need to do today.
Whoa. Oh my gosh.
Now, this example wasn't so bad.
Oh.
You're just adding 1 to k. Instead of k, k plus 1. Where did you But, right, so this and this. Okay, k matches k, k plus 1 matches k. Okay? Alright, let's look at this. What do we have? Here. Do this with some of the sequence. Okay, write it down.
I don't like this.
Okay, so you see this is the rule that we're adding up, right? 3k plus 2, right? PK, p sub k is all of this. Okay. Okay, so p sub k plus 1 is actually the series s of k plus 1. Alright, 2, 5, and 8. They're going to stay the same, right? There's no k, we don't need to replace anything. Alright, now we have this right here. We have 3 times k minus 1. If we're plugging in k plus 1, what does k plus minus 1 turn into?
K.
It just turns into k, right?
Oh, right.
We have k plus 1
Because you're changing k.
minus 1, right? So what we have is 3k minus 2. Now, our 3k minus 2, our k gets replaced with what? I replace k with k plus 1.
Yeah, we have to multiply with 3 in the first place.
Okay, that 3 is being multiplied to k.
Oh.
So the 3 has to be multiplied to the entire k plus 1.
I understood it. 3k plus. You're gonna have to replace which. Why do you replace that?
Because we're writing piece of k. So any k gives a k plus 1 instead. Alright? So 3 times the quantity k plus 1 minus 2, what does that simplify to?
3k plus 1.
What? What? Well, because this is 3k plus 3 minus 2. Okay? Alright, we have one more example, and then you guys will have your symbol.
We did cross, the evidence is the crack of bond.
So is a lot of people, buddy. Alright, last one. Write it down. Alright, so P sub k plus 1. All we have to do is plug in k sub 1. So k squared turns into what?
K plus 1 squared.
K plus 1, the quantity squared. This k plus 1, the quantity squared, turns into
Plus 2 the quantity squared.
k plus 2, the quantity squared. And then over 4. Okay? What? No, you are going to leave it. Okay? Now, ladies and gentlemen.
This
Okay?
function always says that.
Now, please take this assignment seriously. Check 1 and 3 in the back of the book. I will have your Ethan answers tomorrow. Tomorrow is when we're going to get into the meat and potatoes of mathematical induction. We'll actually go through the process of proving something true using this strategy.
Where I come from, it's cornbread and chicken. Where I come from, a lot of